This is a lesson on Hess's law. Heat, or changing heat, is a state function. And previously we talked about state functions where it does not matter how you get there, it's just what your beginning and end results. So that you'll get the same results if it happens in one step or a whole bunch of steps. So you get the same result as long as you start and end up with the same places. The rules, and there are only two of them. If the reaction is reversed, you're going to be given a reaction and how much energy is produced or released. If that reaction needs to be switched around, if the reaction is reversed, then the sign of the energy is switched. If it's positive, it turns negative. If it's negative, it turns positive. Second rule, if you multiply the coefficients by a number, if you need twice as much substance, you'd have to multiply the delta H by the same number. So if you multiply coefficients by a number, you multiply the delta H by the same number. That also works for division, because multiplying by 0.5 is the same thing as dividing by 2. Example problem. Find the change in heat for the reaction N2 plus 2O2 yields 2NO2 if 2NO yields N2 plus O2 and the delta H is negative 180 kilojoules. NO plus 1/2 O2 yields NO2. Delta H equals a negative 61 kilojoules. So what you want to do is alter, change, flip, switch, multiply these so that they add up and equal your target equation. Well, I look for original things that occur in only one equation, like NO2. Here's NO2, and here's NO2. It's the only time it occurs. The NO2 is on the correct side, but down here it is only 1, and you need 2. So what you do is you multiply that equation by 2. Up here, you're looking for N2. That's unique. This is the only time it occurs in any of the equations, N2. Well, the coefficient's the same, 1N2, 1N2, except it's on the back side instead of the front side. It's a product, not a reactant. So that you're going to have to multiply by -1. And that parentheses should be over here, because you're going to multiply everything by 2 and everything by -1, which means flip it. So if you multiply this by -1, that means you get N2 plus O2 yields 2NO. The delta H is equal to positive 180. Okay? You don't really multiply these by negatives, but flip the sides. But this one you actually do change the sign, flip it. 2 of these, 2NO plus O2 makes 2NO2, and the delta H, we have to multiply that by 2, negative 122. Add these up. This is like solving simultaneous equations. The 2NO cancels. Nothing else cancels, but the O2 and the O2 add up to be 2. So it's N2 plus 2O2 yields 2NO2. And you add these two guys up, and you get positive 68 kilojoules. This equation is the same as your target. So that means it's going to be an endothermic reaction with 68 kilojoules of energy needed to be added. Another example, and then we're done. Find delta H for 2 borons plus 3 hydrogens yields B2H6. There's a technical name for that. And now we have 3 subparts. H2O yields H2 plus 1/2 O2 with a 242 kilojoules of energy required. B2H6 plus 3O2 produces B2O3 plus 3 waters, negative 2035 kilojoules. 4B plus 3O2 produces 2 B2O3, negative 2546 kilojoules. Okay, well, what are we looking for? Well, there's B's, and here's 4 B's, and that's the only time it occurs, but you need half as many, so you multiply by a half, or 0.5. Here is B2H6. Here is B2H6, 1-to-1 ratio, but it's on the wrong side. So this is your switch problem. And then here, what are we looking for? Well, let's see. There's going to be 3 waters on this side and 1 water on this side, but there's no water showing up. So what you got to do is you got to get rid of the waters. Now remember, this is switching sides, so this one's going to switch sides and multiply by 3. So you switch them around, you get 3H2 plus 3 halves O2 yields 3H2O, and multiply that by negative 3, negative 726. Multiply this by A1, which means switch it, formula-wise. B2O3 plus 3H2O yields B2H6 plus 3O2, and switch that sign around, so it's a positive 2035 kilojoules. And this one you divide by 2, so it would be 2B plus 3 halves O2 yields B2O3, and divide that by 2, you get negative 1273 kilojoules. Add them up, see if it works. 3 waters and 3 waters cancel. B2O3, B2O3 cancels. And 3 halves water, that would be 3 waters, or 3 oxygens, sorry. 3 halves oxygens, 3 halves oxygens. 3 on one side, 3 on the other. Those cancel. So add them up. 2B plus 3H2 produces B2H6. Add these up, and you end up with 36 kilojoules. Positive, which means it's endothermic again. So it's just playing around with them, switching around. So once or twice, like on here where you had to figure out what to do with this, you had to get rid of the waters, or you had to get 3 hydrogens over here. I guess it would have been a better way of doing it, because there's only hydrogens here. You'd have to have 3 on the other side, so that'd be switching around. I would go look for what you need to do. Look for a unique situation where it only shows up once, and see what you got to do to make it go to the right side. That concludes this lesson on Hess's Law.